today we're going to engage in the solving of problems that concern the midterm exam. Okay, the midterm exam consists of 4 chapters, so we're going to solve 1 or 2 problems from each chapter. Therefore, our first problem is the one that you see on the board. The question says, answer the following questions based upon this market basket. As you can see, this market basket consists of a market basket that consists of 3 goods, namely movie ticket, bags of popcorn, drinks of soda. The quantities are 4 movie tickets, that is, you can consume 4 movie tickets per month or per year, whatever. You consume 2 bags of popcorn, and you consume 4 drink or 4 bottles of soda. In 2008, the prices of each movie ticket is $5. This is the price per 1 unit. So the price of a movie ticket is $5. The price of a bag of popcorn is $3. The price of 1 bottle of soda is $1. Now, in 2009, as you can see, the price has changed. Now, the price per movie ticket is $7.50. The price of 1 bag of popcorn is $3, and the price of 1 bottle of course, soda is $1.50. So, as you can see, the prices have changed. Now, the first question, remember that the market basket is the same for, when you talk about CPI, the market basket is the same for the base year and the other years. As you can see, the weights, these are the weights, the quantities. These are the same for 2008 and 2009. If we have other years, it will be always the same, okay? The only changes is about the prices. Okay, now, the first question is, what is the cost of the market basket in 2008 and 2009, given that 2008 is the base year? Now, when we talk about the cost of the basket, it's like the same thing as the total expenditure on that basket in 2008, which is the base year. So what we do here, cost of the basket. Cost of the basket, or cost of the market basket, is the same as total expenditure of the basket, market basket. In what? In 2000, of course, in 2000, in 2008. So it's going to equal what? We multiply the price times the quantity in 2008. The quantities are constant. So 4 times 5 plus 2 times 3 plus 4 times 1. And we come up with $30. Then, therefore, as you can see, the cost of the basket, or the amount of money spent on the basket in 2008 is $30. What about the cost of the basket in 2009? The cost of the basket in 2009, all we have to take is use the same market basket, which is 4 movie tickets, 2 bags of popcorn, and 4 drinks of soda, and we multiply by the prices in 2009. So, cost of the basket, or the market basket, in 2009, it's going to be equal 4 times 750 plus 2 times 3 plus 4 times 150. And we come up with how much? We come up with 42. So, the total cost of the basket in 2009 is $42, or the total dollar expenditure of the basket. Now, the second, or part B of the question or the problem, is calculate the CPI in 2008 and 2009. Remember, CPI is calculated by using the formula, which is what? CPI, as you can see, CPI in 2008 is equal, of course, because 2008 is the base year, then the CPI in this base year, 2008, is 100. Is equal 100. Is equal 100. Now, perhaps you want to know why 100. Of course, the formula of the CPI, it says the following. CPI in 2008 is equal total dollar or total expenditure of the basket in this year, in the current year, that is the year that here, we're talking about 2008, over total expenditure of the basket in the base year. Now, what's the base year? We said the base year is 2008. Therefore, in 2008, which is equal, we know the total expenditure of the market was in 2008 is how much? 30. The same thing as the cost of the basket. Over 30, we come up with what? 100. Or times 100, of course, here. Of course, don't forget 100. So the formula for the CPI is that the CPI in the current year is equal total dollar expenditure of the basket in the current year over the total dollar expenditure of the basket in the base year times 100. You see over here, it's going to equal what? 30 over 30 times 100. We come up with equal 100. Okay, so as you can see, the CPI in 2008, which is the base year, is always 100. So whenever you encounter a question that says that's asking you to calculate the CPI in the base year, just write the CPI in the base year equal 100. Now, the same thing for, as you can see, if we want to calculate the CPI in the 2009. So let me just change the year here and put 2009. 2009. So here we have 2009. Okay. CPI in 2009. Total expenditure of the basket in, we change this one, 2009. In 2009 over total expenditure of the basket in the base year. Now, let me erase over here, times 100, of course. Look over here. Now, what is the total expenditure of the basket in 2009? We already calculated this. The cost of the basket in 2009 is 42, which is equal 42 over the cost of the basket or total dollar expenditure of the basket in the base year. We calculate that to be 30 times 100. And we come up with what? Is equal, of course, 140. Come up with 140. Okay? So, the CPI in 2009 is equal 140. And the CPI in the base year, we said is equal 100. CPI in 2000, or the base year is 100. And CPI in 2009 is equal 140. Now, what is the percentage change in the prices between 2008 and 2009? Interpret your answer. Now, here we're talking about, of course, the change in the prices between 2009 and 2008. So we can say like percentage change in prices between 2008 and 2009. It's going to be equal CPI 2009 minus CPI 2008 over CPI 2008 times 100. We come up with what? 140 minus 100 over 100 times 100. We come up with 40%. Come on, Dave. What's 40%? Here, the percentage change in prices between 2008 and 2009 is the same as saying the inflation rate in 2009. Yani I could say here inflation rate in 2009 is equal 40%. Now, what that means when the percentage change in prices between these 2 years is 40%. What that means? How do you interpret this? We can say that here, that prices have changed from 2008 to 2009. Okay, and the amount of change is 40%. Therefore, you can interpret this by saying what cost $1 in 2008, now in 2009 cost $40. Plus 40 cents, which means $40. So any good that you bought in 2008, now the price of that good in 2009 is going to increase by 40%. So a good that cost $1 in 2008, now in 2009 costs $0.40. Okay, this is the interpretation of of course, the equation. Now, by how much, last problem, of course, by how much, of course, should the consumer's income change to keep up with what happened between 2008 and 2009? Remember that to keep up with inflation, what happens between 2008 and 2009 is that prices have changed or increased by 40%. Therefore, in order for the consumer to keep up with that change in prices, to keep up with inflation, which equal 40%, then his income should increase by 40%. So to answer this question, we say his income should increase by 40% to keep up with inflation of 40%. Therefore, now we move to the second question concerning the midterm, sample of questions, the midterm exam. Okay, this problem 2 is course from the chapter about nominal GDP and real GDP. As you can see here, we have a table of goods that are produced in a certain country X. As you can see, the country is producing bikes, cakes, and flour. Now, he's telling you that flour is an intermediate good, okay, which means that does not enter in the production of final goods. Therefore, when we measure the value of GDP, we exclude flour from the calculation of GDP because it is an intermediate good. So once you include that intermediate good in the production, in the calculation of GDP, then you are double counting, of course, the value of GDP. Therefore, you should exclude the intermediate good. And now he's saying 1908 is the base year. Therefore, let's begin with part A. Part A say calculate nominal GDP, the nominal GDP in 1998 and 1999. So what we do, we don't, of course, calculate or we don't include flour in the calculation. So nominal GDP, actually, when we say about nominal GDP, we mean the value of production or the measure of production at current prices. What's current price here? 1998. Okay, so we say nominal GDP in 1998 is going to be equal 5 times 150 plus 20 times 100, and we'll come up with, of course, $2,750. This is nominal GDP in the 1998. So we did not include flour because it is an intermediate good. Now the same thing, nominal GDP in 1999. Of course, we say 1999. We have to, of course, use the 1999 prices times the quantities in 1999. So we come up here with, of course, 10 times 230 plus 20 times, of course, 110, and we come up with, of course, 4,500. Okay, this is, of course, the value of the nominal GDP in 1999. Now, calculate the real GDP in 1998 and 1999. Remember that when we say about real GDP, when we talk about real GDP, we mean the measure of production or output at constant prices, at the base year prices. So we measure the output at constant prices. What is the constant price here? 1999. He said, take this one as the base year. So we have to multiply the base year prices, okay, which is 1998 prices, times the quantities in 1998 to come up with the real GDP in 1998, and to multiply the base year price in the quantities in 1999 to come up with the real GDP in 1999. So let's start here. So real, of course, GDP in 1998 is the same as the nominal GDP in 1998, okay, which is equal, of course, 5 times 150 plus 20 times 100. We come up with 2,750, which is the same as nominal GDP in 1998. Now, real GDP in 1999, of course, we're going to take the base year prices, which is in 1998, which is 5 times 230 plus 20 times 110, and we'll come up with 3,000, of course, 350. 3,350. Okay, so as you can see, real GDP, now, as you can see, that nominal GDP take into consideration the change in prices as well as the change in quantities. Of course, however, real GDP only takes into consideration the change in quantities because the prices are fixed. So now, as you can see, the value of real GDP is much less than the value of nominal GDP in the same year, 1999 here, 3,350, over here 4,500, because here it takes into consideration, nominal GDP in 1999 takes into consideration the change in prices and the change in the quantities. However, the real GDP takes into consideration only the change in quantities. Now, calculate the GDP inflator in 1999, 98, and 1999. So GDP deflator is going to be equal in 1998, is going to be equal 100, which is equal nominal GDP 1998 over real GDP 1998 times 100, which is equal, of course, nominal GDP, it's 2,750 over 2,750 times 100, which is equal 100. So GDP inflator in the base year is the same as the GDP deflator, of course, GDP inflator in the base year is always 100. It's like, the CPI in the base year is always 100. Okay, now we need to calculate, of course, GDP inflator in 1999. So let me here, of course, erase here, put 1999 in this equation, 1999, okay? It's going to be equal, not 100 here, of course, I take this one, which is equal nominal GDP 1999 over real GDP 1999 times 100. So let's change this one here. What is nominal GDP in 1999? This is nominal GDP in 1999, which is 4,500. 4,500 over real GDP in 1999, which is 3,350 times 100, which is equal, of course, a deflator in 1999 is going to equal 134. 134.3. Okay, this is the, of course, G deflator in 1999. And we learned that G deflator in 1998, the base year is 100. Okay, now the third part D, calculate the percent change in prices between 1998 and 1999 using G deflator. Okay, or using CPR, same thing. Now, since we have the calculation of G deflator in 1998 and 1999, we can find the percent change in G deflator between 1999 and 1998. So percentage change in GDP deflator is going to be equal between these 2 years, of course, between 1998 and 1999 is going to be equal 134.3 minus 100 over 100 times 100, or we come up with 34.3, of course, percent. That's what you get here, 34.3%. So, as you can see, the prices between 1998 and 1999, and of course, the change in prices between these 2 years is equal 34.3. What that means to you? It means, or the interpretation of this is that what cost $1 in 1998, now in 1999, costs $34 cents. $34.3 cents, an increase of 34%. Now calculate the economic growth between 1998 and 1999. Listen, now when we talk about economic growth will exist or will take place whenever the real GDP in 1 year is greater than the real GDP in the previous year. So here, of course, you're going to come up with a positive. So what you do here, of course, economic growth is going to be equal, of course, between these 2 years, of course, between 1998 and 1999 is going to be equal, of course, real GDP in 1998 is going to 33, minus real GDP in 98, which is, of course, 2,750 over 2,750, okay, which is, let me basically write the formula first. It's better. So it's going to equal real GDP 1999, because 1998 and 1999, minus real GDP 1998 over real GDP 1998, okay, and don't forget here times 100. Therefore, economic growth between these 2 years, 1998 and 1999, is equal real GDP in 1999 minus real GDP in 1998 over real GDP in 1998 times 100. And this, when you of course plug this number, you're going to have 3350 minus of course 2750 over 2750 times 100, and we come up of course at 21.8%. This is the economic growth. Of course, as I said, economic growth means or take place when the real GDP in 1 year is greater than the real GDP in the previous year. Okay, this problem 3 is from, of course, the aggregate demand, aggregate supply chapter. The problem consists of two parts, A and B. Part A says in 2001, President Bush of the United States, of course, decreased the income taxes for individuals in the United States, of course. Explain graphically. So you have to, draw a graph of aggregate demand and aggregate supply. When the question asking you to show the problem graphically, then you have to draw a graph of aggregate demand and aggregate supply, of course, with labeling everything along the vertical axis and along the horizontal axis. So now explaining graphically using aggregate demand and aggregate supply, how this, of course, policy affects the price level, the level of GDP and unemployment. First of all, let's focus on the income taxes. Now, we know that disposable income, remember that disposable income, let's symbolize it by YD, is equal Y, the income, the actual income that you take, that you get. Of course, it is the income that you get minus income tax, minus tax. Okay? Now, as you can see from this equation of disposable income, now when income tax decreased, that implies disposable income will increase. As you can see, when income tax decreased, then that means YD, disposable income, will increase. So we know that consumption, is a function of disposable income. Consumption is a function of disposable income. So consumption is a function of YD. And when YD increases, consumption will increase. When your income after taxes is higher, that implies your spending will be higher. That is, your consumption will be higher. So consumption is a function of YD. So when income, therefore, when YD increases, that implies C increases. But C is a factor of aggregate demand. However, C, consumption, is a factor of aggregate demand, because aggregate demand is equal C plus I plus G plus net export. Okay. So when C increases, aggregate demand will increase, which implies here aggregate demand will increase. This implies it shifts to the right. Now, let us show that graphically, because he is asking you to show the problem, of course, graphically. So let's graph this. Look over here. This is, we draw XY plane. Along the vertical axis, we put the price level, of course, and along the horizontal axis, we put real GDP. Okay? Now, we draw the aggregate demand, which is downward sloping. Okay, and we draw the short-run aggregate supply, short-run aggregate supply. Okay, remember here, short-run aggregate supply is the same as short-run aggregate supply. Okay, SRS stands for short-run aggregate supply. So we have short-run aggregate supply, as you can see, is upward sloping. The intersection of aggregate demand and short-run supply is here. Here, of course, draw a horizontal line to, of course, intersect the vertical axis. This will give us price. Let's say price, okay, price star, and this is here a quantity star. It's equilibrium price and, of course, equilibrium quantity. Is that clear? Now, so this is the original market, the original economy. There is an equilibrium. The equilibrium in this original market, before any changes in the economy, any factor, before any change in any factor in the economy, this is what we get. Now, of course, engage the changes in the economy. What happens? We know that the short-run supply is fixed. No change in the short-run supply because, the increase or the change in consumption will only affect the aggregate demand. Therefore, only aggregate demand will change. So aggregate demand, it shifts to the right. This shifts to the right, as you can see. AD1, from AD0 to AD1, shift to the right. Now it intersects the original short-run supply here. Now, let's look at the new price. As you can see, this is the price. P, let's say 1, and the quantity is 1. So the quantity increase and the price level increase. So as you can see, price increases, quantity or real GDP increases, level of GDP increases, and what that means. When GDP increases, that implies, this implies that the higher amount of output or the increase in the amount of output implies that more workers are getting work. Therefore, less workers are unemployed. Therefore, the increase in GDP means lower unemployment rate. This implies lower unemployment rate. And this is exactly what we want. From this, of course, as a result of the increase in aggregate demand, the price will increase, the level of GDP increase, and of course, the unemployment rate will go down. We have lower unemployment rate. That means we have, of course, an inverse relationship between GDP and the unemployment rate. When GDP increases, the unemployment rate will go down, and when GDP decreases, the unemployment rate will go up. Okay. Now we move to the second equation, or the second part of the question, which says explain graphically using aggregate demand and aggregate supply. The increase in the interest rate, of course, in the interest rate by the central bank. The increase in the interest rate by the central bank in the economy. Yeah, we need to, of course, use aggregate demand and aggregate supply. Of course, we have to use a graph using aggregate demand and supply to, of course, study the effect of the increase in the interest rate in the economy. Hint, of course, assume, of course, that the economy is at full employment before the increase in the interest rate. So first of all, of course, let's start from here. Of course, graphically, of course, we could graph it like this. Price level here, real GDP here, aggregate demand is downward sloping, short-term aggregate supply is upward sloping. What you have here, long-run aggregate supply, or this is what you get here. The economy is at full employment. That means at, of course, QM, where QM is full employment output. Full employment output. Okay? This is the original. This is the economy is here. And this is the price, P1, okay? This is the graph of the economy at full employment. Now, let's, of course, explain more in more details about the increase in the interest rate. Now, when this is the interest rate, increases, that implies cost of borrowing will increase, which means less loans are taken. Usually, who takes loan? The firms and the consumers who usually buy durable goods. Consumers who buy, for instance, a car, a watch, a nice and expensive watch, a nice and expensive mobile, a furniture. So they have to spend lots of money. So in order to pay for these durable goods, consumers, of course, they go to the banks to get loans. And when the cost of getting that loans, that means the interest rate is so high, they will get less loans. That means their consumption will go down. The same thing, apply for the firms. Firms usually to engage in or to invest more, then they have to take loans. And when the cost of getting that loans from banks is very high, then their loans will go down, which means their investment go down. So here, what we said here, of course, which means that less loans are taken. That implies, of course, C, consumption, and investment will decrease, which implies aggregate demand will decrease. That implies it shifts to the left. Let's apply these over in this graph. So here, there's no any change in the short-term aggregate supply. The only increase, of course, is taking place with the aggregate demand. So the aggregate demand will shift to the left. Let's shift to the left this way. Aggregate demand as you can see, shift to the left from AD0 to AD1. It intersects the short-term aggregate supply here. What happens here? As you see the price, of course, let's see here, price 2. Price will go down and the quantity will go down to Q2. So here, of course, what we see, of course, is that Consequently, as a result of this, as a result of making the changes, as a result of the increase in the interest rate, we see that price decreases and Q decreases. And when the Q decreases, this implies that the unemployment rate will increase. So which implies unemployment rate will increase as a result of the decrease in output. Okay, now we have the last problem number 4, of course, concerning the classical theory. We know that the classical theory is based upon certain important assumptions, or beliefs, mainly that the economy is self-regulating, it regulates itself by itself, it's based upon Say's law that supply creates on demand, and also the classical economists believe that interest rate, wages, and the prices are flexible. They move, back and forth, of course, in response to any changes in the economy. And also they believe in laissez-faire economy, which means non-interference policy. They don't believe in any intervention by the government in the economy. So these are the main beliefs of the classical economists. Now we have this question. The below graph represents the Lebanese economy in the long run equilibrium. This is the Lebanese economy. It's long run where Q is equal to QM. The level of the short-term equilibrium is equal to the full employment output or natural GDP or potential GDP. So when we say about natural GDP, we mean also the full employment output. Also, we mean the potential output. So let's represent this one by the letter QN, which stands for the natural GDP or potential output or full employment output. So the Lebanese economy is at point 1, where aggregate demand intersect the long run aggregate supply at point 1. As you can see, all these 3 curves intersects at 1. Now, assume that the government increased taxes. Answer the following questions. Show graphically the new state of the economy. Now, as you know, when taxes increase, taxes increases, that implies, of course, disposable income, of course, decreases, which implies, that consumption will decrease. Taxes increase, that implies disposable income, which is equal to Y minus T, will decrease. And the decrease in disposable income means the decrease in consumption. And since consumption is a factor of aggregate demand, then aggregate demand will decrease, which implies aggregate demand decreases. Okay? Now, of course, that could be also, applied to firms. When business taxes, of course, increases, that implies the profits of the firms will go down, which implies that their investment will go down. So in both ways, we will expect aggregate demand to decrease. So as you can see, aggregate demand decreases, which means shift to the left. So let us, of course, show graphically the new state of the economy. So we can write this one here. Real GDP. This is price level. This is aggregate demand. Short run aggregate supply. Of course, this is the long run aggregate supply. This is, as you can see, QN here. And this is long run aggregate supply. Now what happens? Aggregate demand decreases. That means it shifts down this way. This is AD0. That means AD1. So aggregate demand will intersect the short energy supply here at point 2. So which implies, of course, P1, P2, which implies that the price will go down, and of course the equilibrium output will go down to Q2. So as you can see here, we are at point 2. So we are at point 2 producing a level of output that is less than Qn. So here, conclusion that, of course, the net result or the effect of the increase in taxes is that we have a recessionary gap. We have a recessionary gap. What that means, recessionary gap? It means that the level of output, the short-term level of output, is less than the long-run level, equilibrium level of output, which means that Q less than Qm. This is a recessionary gap. Now, part B saying, according to classical theory, the economy regulates itself by itself. That's what we said about the classical beliefs. Without any intervention. We stated those beliefs just a couple of minutes ago. Now, state the self-regulatory process and indicate the final effects on real GDP and price level. Of course, as you can see, using the new drawn graph, the economy is in a recessionary gap. This means the level of unemployment at Q1, at Q2 here is greater than the level of unemployment at Q1. This implies we have a surplus in the labor market. As a result of this surplus, in the labor market, what happens here? We have a surplus in the labor market, which means we have few openings, few vacancies, and lots of workers who want to work. Therefore, as a result of this situation, then the wage rate will go down. As we said, the classical economists believe in the flexibility of wages, which means that the wage rate will, of course, be pressured to go down. So, because of the surplus, of course, we will experience a decrease in wages. We know that wages are a factor of short-term energy supply. So when wages go down, of course, that implies a cost of production will decrease, which implies short run aggregate supply will increase. Short run will increase will continue to increase until it reaches what? Reaches the long run aggregate supply here. This is short run as you can see here. Short run supply will continue to decrease until it intersects the long run supply, here, because the classical economists believe that the economy eventually will go back to long run equilibrium. As you can see, it went back now to long run equilibrium, and it at 0.3. As you see here, 0.3. Now it went back to 0.3 here. Okay, we started from 1, we moved to 2 in the recessionary gap, and then we went back at the end to 0.3, where the level of output, of course, goes back to QN. However, but at what? At a lower level of prices. Okay, so here we can see short run supply. So short run supply will increase until output is back to long run equilibrium. Until output is back to the natural real GDP QN. But this, of course, at the expense, it comes at the expense of lower prices. As you can see, the final effect is that output is back to long run output, which is QN, but the prices went down to P3. Okay, so here we can see that Q equal QN and price is equal P3. These are the final effects of course, this whole process.